Hi everyone, we're going to state the number of positive real zeros, negative real zeros, and imaginary real zeros for each function using Descartes' rule of signs. Now Descartes' rule of signs is for real numbers, but we can, once we get this information, we can also determine the number of imaginary zeros. So let's look and see what we have. For the positive reals, what his rule of signs says is that if I plug in P of 1 and copy down the coefficients of that, I'm going to get 16, 6, negative 7, and 3. Now, when I look at the difference for this, I'm going to have no sign change, one sign change, and so this is a yes sign change, and this is another sign change. So we have a total of 2 sign changes. So possible reals is 2, or for Descartes' rule of signs, you can go less than this by an even number. So 2 or 0. Now for your negative reals, you would basically do the same thing, but instead of P of 1, we're going to plug in P of negative 1. And that's going to change this sign and this sign. It's not going to change your square. So if I plug in negative 1, I'm going to get negative 16. I still have the 6. Positive 7, and 3. So if you look at the sign changes, this is a yes, and these are no's. So you only have one negative real. So 1 is your only answer for that. All right. Now we can determine the imaginary reals looking at what we have. Our degree is 3. So we have a total of up to 3 real solutions, or 3 solutions. We have to have 1 negative. So we only have 2 left. If we have 2 positive, then for our imaginary, I can't even spell imaginary, if we have 2 imaginaries, then we'll have, or 2 positives, we'll have 0 imaginaries. If we have 0 positives, then we'll have 2 imaginary. All right, so you base it off this, and that our degree is 3. So we're either going to have 2 positive reals and 1 negative, or we'll have 0 positive reals. That means we'll have 2 imaginaries and 1 negative. And that's it. Thank you. Have a nice day. Bye-bye.